Well, welcome to Unit 1, Lab Skills. To this day, I remember an event that took place in my high school chemistry class. We were working with sulfuric acid in these test tubes. Now, during one of the experiments, the test tube I had broke and the glass cut my finger. Now, if you've ever experienced lemon juice in a paper cut or a scrape, that's nothing compared to having sulfuric acid in a fresh laceration. Ugh. Well, I tell you that story to underscore the importance of what you're going to learn in this first unit. Okay? It's said that good judgment comes from experience and experience comes from poor judgment. Now, you know that one way of learning is to learn from others. And learn this module well. Pass it on to your students. Apply it to your classroom. For their safety and for yours, let them develop good judgment, okay, without experiencing the consequences of poor judgment. In this unit, we'll also cover this thing called the scientific method. The scientific method is just an organized process for finding an answer to a question. The scientific method is often attributed to Sir Francis Bacon, but the origins of this scientific method can be found all the way back with the ancient Greek philosophers like Aristotle, Leucippus, and Democritus. Now, more recently, the process of organized experimentation was formalized and emphasized by this guy named Robert Grosseteste, and he did this around 1200 AD. Now, from this book that I'm going to share with you, okay, it's called Scientists of Faith by Dan Graves. He says, Grosseteste founded the Oxford School of Thought, whose major achievement was to create a modern conception of the experimental method. He was the first Western writer to dig systematically into the role of experiment in scientific inquiry. Although the Greeks and Arabs had already performed scientific experiments, they never consciously formulated the rules of induction and experimentation as applied to scientific theory. Today, we use the scientific method to ensure the results we achieve are repeatable and attempt to minimize the influence or bias or prejudice in the experimenter. It provides an objective, standardized approach to conducting the experiments, and in doing so, improves their results. And all of this aligns with what we know from 1 Thessalonians 5:21 that tells us to test everything and retain what is good. Now, these repeatable results lead to development of scientific models, and then confirmation of those repeatable results by objective, independent parties can lead to those scientific models becoming scientific theories. And a theory that can be distilled down to a very concise and general statement that describes phenomena in nature is known as a scientific law. Now, in these days where we're encouraged to follow the science, it's imperative to know that scientific laws can never be known with absolute certainty, because it's impossible to perform every single experiment to confirm the law. Scientists operate under the assumption that all scientific laws and theories are valid until a counterexample is observed. If a good quality verifiable experiment contradicts a well-established law or theory, then that law has to be modified or thrown out completely. A classic example of a proven theory in law that was overthrown completely was this theory of spontaneous generation. So here's what I need you to take away from all of this. Science doesn't prove anything. One final area we're going to cover in this unit is measurements. In nearly all chemistry experiments, we make measurements. And it's crucial to know and to acknowledge that in every measurement, there's some amount of uncertainty. Whether we use analog or digital devices for our measurements, there is always some uncertainty in every measurement. For example, how long is this red line? From the ruler, we can see that it reaches from the 0 mark to somewhere between the 3rd and 4th marks after the number 2. So that means it's somewhere between 2.33 and 2.34 centimeters. There is uncertainty in our measurement. Now, here's a fun exercise you can do with your students to help them experience the uncertainty in measurement. They're going to measure how tall they are, once before going to bed, and again the next morning when they wake up. before they go to sleep, after they crawl into bed, have them get a helper to measure the distance from the top of their head to the bottom of their feet and write that number down. Then, in the morning, have the helper measure them again. Write down that number and then compare that number to the number they got the night before. The numbers won't be the same. And this is how they will see there is uncertainty involved in every measurement. Now, to accommodate these uncertainties, there's really two things that we're going to do. One, when measuring, we will make multiple measurements. And two, when working with actual numbers associated with our measurements, we will use what are known as significant figures. Oh, and remember, every measurement has units associated with. Teach your students to always write down the units associated with each measurement. Because as I've discovered both as a student and a professor, if you pay attention to the units, it will save your bacon.